Good evening, everyone. This is Observe, Wonder, Think, a Green Chemistry Interactive webinar. This evening, we have a fantastic presenter, Annette Sebuyira, and the topic will be toxicology. So briefly, here's our agenda for the evening. I'm going to make some acknowledgments and introductions. I will set the conversation guidelines, and the presentation and discussion will be on toxicology, as just mentioned, and then we're going to talk about some professional development opportunities at the end. So first of all, the land acknowledgement. Tonight, we humbly wish to acknowledge this unceded land on which Beyond Benign operates. For years, it has been the traditional land of the Pawtucket and Massachusetts nations. We acknowledge the painful history of genocide, colonialism, and forced removal from this territory. We also acknowledge that further education is needed on our part to learn the full history of the land we occupy and all the indigenous peoples it belongs to. We encourage all of you to explore the history of the land you occupy and the indigenous people who were there before you. There is a link in here that you're going to be able to access later on to learn more about this. So I am the coordinator for this year's Observe, Wonder, Think. My name is Esther Hines, and we welcome and encourage you to turn your camera and microphones on, especially during our collaborative portion. Will be a very good one this evening, which will not be recorded. We are only recording the presentation portion. We will be monitoring the chat where we will share a great deal of information with you, and also for you to share with us to be inclusive and to encourage engagement. We would love to hear a little bit about you too. So please tell us what you would like to take away from today's session and in the chat, and introduce yourself if you haven't already. Additionally, we ask that you rename yourselves to the name you would like printed on the Professional Development Credit Certificate of Attendance. It helps us understand who our audience is and where they're from. Thank you very much. All right, so I'm going to introduce now our presenter for tonight. That is Ms. Annette Sebuyira. Annette is a New York State Master Teacher Emeritus, a National Board Certified Teacher, and an adjunct professor for Syracuse University, and a Beyond Benign Certified Lead Teacher. Annette earned a master's degree in science education and taught science at the Guilderland School District for 31 years. During her tenure with Guilderland High School, Annette taught AP Chemistry, SUPA Chemistry, and SUPA Forensics. SUPA is a dual enrollment program that allows high school students to take college-level courses taught by Syracuse University. She also taught reagents and honors chemistry. In 2013, Annette attended a Beyond Benign workshop through a grant by DEC at Siena College, and that experience forever changed her life. She has been passionate about green chemistry ever since, has implemented the green chemistry principles in her teaching, and co-facilitated the New York Science Green Chemistry Professional Learning Team that met virtually for 4 years until she retired from teaching in 2022. She has continued her support of green chemistry and Beyond Benign by becoming a certified lead teacher today. Welcome, Annette. Let me stop sharing my screen so you can share yours now. Let's see.
Thank you so much, Esther, for that lovely introduction. Good evening, everyone, and thank you for giving up the first warm night to spend some time with us. So I'm going to share my screen right here. Come on. All right. Did it come up?
I don't see it.
Got it.
Now it is. Yes.
Yay. Okay. So let's just make this big. Okay, so tonight's presentation is going to be about toxicology, which is something that I never learned when I was going through school. I never took a course on it, but I would like it to be interactive. So if you, on your devices, if you could type in joinpd.com and then just enter that code, that will put you right in our class. I got 2, 3, 6. Yay. Okay, beautiful. Okay, so I'm going to start the class. So welcome to Observe, Wonder, Think. April 17th. We had snow yesterday. I don't know about you. So this is what's happening. This is what we are living with right now. And as mentioned, a person who's done all these things. I didn't recognize that person. Could be me, but that's me. Passionate about green chemistry and all the 12 green chemistry principles. I retired back in 2022. Continue to keep my feet dipped in there by being a contractor for Beyond Benign. And I learn every day. I continue to learn. And it's just an endless journey of learning. So I know that you were asked to do this, but why don't you type your name and pronoun, indicate where you're joining from, city and state, and then what is green chemistry? And you're going to see. Look at that. Okay, shout out to New York City. We got Berkeley, California. We got New York, New York. Okay. Beautiful. Nice. Okay, I'm going to hide this so that you don't feel put on the spot while you're writing. So I'll give you a few minutes to write. But it's always interesting to me with the knowledge and the perception that we all come in with, because we all have the same goals to save our planet, keep ourselves safe. However, we each bring such different information with us. And that's why I love these groups, because we can continue to learn from each other. So I can see that people are pausing. So why don't we show the responses? Okay. Green chemistry is a way to connect students to their sustainable futures and applications of cradle to grave sciences for everyone. I love that. Okay. Green chem is doing chemistry in a more sustainable and safe ways. Buzzwords right there. Sustainable, right? Green chemistry is sustainable. I see that everywhere. Conducted responsibly. I love that. Preventing pollution and harm to us. Okay. It's a lens of seeing the world. Amazing. Really, really good. Okay. Okay. We actually are coming as far as, we have Wilmington, Massachusetts, Bedford, Wilmington. You're going to see a little bit about that. The design of products and process. Excellent, right? So this is something that each of us, if you've attended at least one OWT, you've learned this. If you've attended a GCC webinar, you've learned these, and now you're beginning to see it. Frankly, in my dreams, I am hoping that it's not green chemistry, it's just chemistry, whereby it's safe for everyone and we don't have to underline it, just like some of the conversations that we were having. Okay, now let's see your artistic nature or writing. There's a part whereby you can just type in, you just choose the text response. 2 things you already know about toxicology. Love that. Okay, so it's toxicology, dangerous fumes. Um, this is probably skull and crossbows, toxic, danger, Don't you love this, guys? Give me a thumbs up if you like this. Who knew I'm sitting with all the Picassos of the world? Okay, you know that the concentration, the dose is important, the molecular structure matters. We know that the father of toxicology is Paracelsus. Beautiful. Okay, and the dose method, yep, I love that because anything can be poison. Okay, it's the science of poisons. It involves understanding of the hazards, right? And, we're still going with our drawings. But, as you look at this, does anybody see the link to what you told me about green chemistry in the beginning? Sustainability, right? So toxicology is study of all the things that would negate that, right? So that if you had the background of toxicology, it's going to make you a better green chemist. Okay? It's going to make you a better citizen. So, is this the book about the poisonous? Please feel free to chime in and share. You can speak, unmute. I didn't want to show who's who on the names because I don't want people stealing your thunder right there. But chime in anytime you want to, guys. Okay. So there's toxicology, when you think about a mental picture, what image do you see when you hear the term toxicology? What comes to mind? What types of practices are you thinking about? What type of exposure? What type of molecules are we thinking about? So that's where we're going to deal with tonight. Okay. Now I just want to get an idea of what do you wonder about toxicology. So you've found out who the father of toxicology is. You found out what it might cause or what it means. This page here is a wonder about toxicology, maybe some questions that you will have for me later. So if you could just do a response on it, I just going to want to make sure that I cover that question, that I respond to it. Okay. Impact on life. Scented candles, what's being given off by them? How can we make it accessible? How can we connect students with the world? Beautiful questions. I think this one is about the Daphnia, the lab with the Daphnia, the LD50. I'm glad to see that most of the wonders that we have right here are things that I put in our topic tonight. Are there any commonly used materials that would be useful to know the toxicology mechanisms? Beautiful, beautiful. And what would be the basic when teaching toxicology? I love this. Okay. Thank you all for sharing. So let's see what I can help with tonight. All right. How many of you remember this train? 2 summers ago, the freight train derailment in the village of Pennsylvania. It was on the Pennsylvania state line, including 11 cars transporting hazard materials. The area residents evacuated, and days later, officials fearing possible uncontrolled blast intentionally released and burned the toxic vinyl chloride from 5 rail cars. They were sending flames and black smoke into the sky. I'm sure you guys remember that in the news. Investigators from the National Transportation Safety Board, excuse me a second, from the National Transportation Board later determined that it wasn't necessary to burn this. So when you think about toxicology, when you think about pollution, when you think about industry's part in that, when you think about a chemist's part, the teachers, the schools, all that, no one ever sets out to harm the world. Nobody ever sets out to harm the environment around it, to harm the people about it. However, it's those unintentional consequences that end up being the legacy chemicals that we find in our labs, the poisons that we find being in our landfills, the explosives that are taking place as we transport materials that we need. So when you introduce this is what I do with the students. I always try to find an article that sort of provokes what is going on. Usually when I was teaching and an event took place, any kid who brought in either a hazard, a news event, or something that touched what we were studying from got extra credit. So I wanted them to be senior science citizens, citizen scientists, and know what was around them. So kids continuously brought this in, especially if it was in our neighborhood or in our backyard. So here's my question. You guys tap in. Is this statement true or false? Industry is intentionally increasing the pollution levels. See that? Twice as many people feel that it's false. I'm actually going to try and reduce it. You can see more of more of the screen. So 2 people think it's true, 5 people think it's not, it's false. And so let's talk about that. When we think about pollutions or industries' role in toxicology, we want to know why. So what is the why and how of green chemistry? Because green chemistry directly links us into the study of the toxics that are put into our environment and in our bodies and in our surroundings. So I just wanted to say that I stand here on the shoulders of giants, and I wanted to include this. This is the Beyond Benign website. And on the page, under the New York hub, you'll find the problem. And the main problem is many teachers are put into classrooms with hazardous legacy chemicals and are held liable for the dangers to the students. So it is important to know that decreasing the hazardous chemicals in classroom labs both decreases the risk to students and teachers and increases the sustainability for human health and the environment. Real environmental change can be made in the chemistry classroom. And you know, that is such a positive way to look at things and know that there is a way, no matter what it is that we found in our classrooms, there is a way to curb that and protect ourselves and have more sustainable practices and become safer and keep all our students safe. So on this amazing site, you can hear from teachers. And here's a picture. This is our friend right on the screen tonight. This is Scott. We have Cassie Janova, who teaches the introduction to one of the introduction green chemistry courses over the summer. We have Steve, who's an author. We have Annette back here, who's presenting to you. Amy, shout out. So really good team of teachers that got together and decided that, let's get resources to help with this. When you go on the site, you can either hear from Scott, myself, and Jim. You can find resources such as some labs that were filmed in my kitchen during the pandemic, green titrations. You can find lesson plans that were submitted by green chemistry teachers, certified lead teachers. And so there's all these resources so that if I don't get to cover everything with you tonight, you know to just go to this link, right? And of course, there are more resources, but it's on the Beyond Benign website.
If we were in a public forum, this would be one of the moments where I'd be asking everyone to give a round of applause, because I think it's amazing how much interactivity and development went into this presentation, and both the admission of students and teachers into the process to be interactive. It's the student voice that gives rise to the most interactive and most developmental lessons where students have to see themselves being heard. And I couldn't be more happy to have been involved in this in any way. So I'm so happy that we're able to see this experience, and also, this is a lesson to all the first year, second year, and third year teachers who are in the audience, if they happen to be here, for planning the backup plan. You have to plan for the plan for the plan to go, plan for the plan to go off the rails, and plan the backup plan. And all of that comes into play, whether you'd like it to be or not. And I think that Annette is being superbly phenomenal with her development of her plan today. And I couldn't be prouder to be in her audience today.
Yeah.
Our webinar. Okay.
Thank you. Okay, so let's try this.
Yeah, that sounds like a great resource, even for higher ed educators, because being in higher ed for the last 10 years, I've never used that actually. And I wish I had known about it years ago to had used it with students. So now I might be able to use that with our team even.
Yeah, thinking of some workshop spaces that might be
Yes,
wonderful and
absolutely.
also, yeah.
Aw, you guys rock. All right. So I'm going to try and share again. If you just came in, if you can just go to, I'm not sure if I kicked everybody else off.
I'm
You may
still
have-
on, so we're good.
Are you
I'm
guys
still
on?
Yep.
All right. So I shared a little bit about, all the resources that you can find so that in the end, if I do not get to it, you've seen where it is and how it interacts. I only shared the New York hub because that's where we did most of the majority of the work that I'm involved in. And, we wanted green chemistry to mushroom in New York State. And so those were the efforts that we put forward. So I have the privilege of teaching, an advanced green chemistry course for Beyond Benign during the summer. And my topic is always toxicology connections for chemistry classrooms. This is my topic 4. In this class, we talk about the awards for the green chemistry practices. They used to be called the presidential awards, but now green chemistry award part. We talk about how to implement toxicology in the classroom, how it's linked to that. And so what I end up doing with my students is that I task them to do some certain activities so that we can share in a group activity how to introduce this in the class, which was one of the wonders that we had in our second slide. So when we talk about toxicology, out of the 12 green chemistry principles, the 3 main ones are prevention, less hazardous chemical synthesis, and inherently safer chemistry for accident prevention. Those are the 3 major ones. And what I would do is that with the classes, I show examples of what industry is trying to do in order to engage and be involved in green chemistry practices. So for the less hazardous chemical synthesis, you can see this part over here. What these are actually, in your TV, you have that vibrant HD look, and that's brought about by cadmium selenide. Now, that cadmium selenide is what gives that beautiful glow or HD look, whereby you're looking at the images and you feel like you're in the same soccer field as Lionel Messi, that kind of thing. And so what happens here is that you're redesigning of chemical synthesis, the starting materials and solvents used to make cadmium selenide particles are really toxic. So what scientists developed is a new way to make the particles that use less toxic starting materials. The new method of making the particles reduces the amount of toxic waste that is being produced. So they're reducing the waste that they're going to dump into our landfills. And so these cadmium selenide particles, they're made to glow different colors and are used in our TVs and our phone screens. If you look at principle number 4, designing safer chemicals. So that's a ship. That's the hull of a ship that you're looking at. And before, scientists designed a ship coating material that kills plants and animals that grow on ships, but causes less harm to the marine environment. Because before, they would wash the ships off to get rid of all the mollusks that were stuck on it, but then those would poison the aquatic life. If you look over here on number 5, which is one of the ones that I savor solvents and auxiliaries, over here, a method was found whereby they use ball bearings to increase surface area of metallic particles so that they don't use too much of the solvent to dump into nature. So what's happened here is that instead of using solvents to bring reactants into contact, ball mills are used. They use ball bearings that can be reused many, many times so that the reaction and the collisions take part on the ball bearings. After the reaction, they're cleaned off and reused. Before, we used to have the collision within the chemical reaction and then would throw away all the waste. And one more that I would have liked to share is this one here, designing for degradation. We remember, I think one of the things that got people thinking was the use of DDT the use of DDT was a huge to kill pesticides back in the 60s and the 50s. But the side effects were devastating. Birds' eggs thinned out. We had whole species of habitats destroyed. So pesticides are needed to control the spread of mountain pine beetles, which have damaged large trees of western United States forests due to warming climates. And so what happens now is that we can spray the carbamate insecticide on a pine tree to protect it against beetles. So we're doing many safer ways. So I just wanted to emphasize some of the ways in which the green chemistry principles can be used to help industry and to help us. Okay. So remember I told you that when I was attending school, I never learned about toxicology. And then when in my introduction, you heard that I participated with Super Forensics. Super stands for Syracuse University Project Advance. And in it, I became an adjunct for Syracuse University, and I was trained to become a forensics teacher. That's when I came across one of the topics. It was forensic toxicology. The definition of toxicology, as some of you alluded to, remember in the first slide when we talked about it, it's a study of the adverse effects of chemical substances on living organisms, as well as the practice of diagnosing and treating exposures to the toxins. So in forensic toxicology, it's a huge branch. What it does is that it determines the cause and effect relationships between the exposure to a drug, someone asked about that, poison or other substance, and the toxic or lethal effects of such an exposure on the human body, including the prevention or improvement of such effects. So there are going to be observable changes to an anatomical or bodily function. There's going to be an acute versus a chronic effect. There's going to be warnings versus benefits. Forensic toxicology has five different divisions. There's postmortem, where the pathologist is going to tell you what they found after they perform an autopsy. There's the criminal, whereby they have chemical labs that study intentional dope poisoning, including, so for the DUIs and alcohol poisoning, those are all under this same branch. Then there's workplace, whereby there's drug testing is especially important for pharmaceutical companies. Then there's sports, the growing use of steroid testing. And then the environment, where this is where industry comes in because of the waste. And of course, there's terrorism, because this is on a large scale. In forensic toxicology, you can also talk about toxin exposure. Was it intentional, accidental, or deliberate? You could also talk about factors that affect the substance toxicity. What was the dosage? What was the chemical makeup of the substance? How did it enter your body? Did you inhale it, ingest it, intravenous? What was the physiology of a victim? What was the drug interaction from medications? What was the exposure? So it's such a large group and intense concentration of what has to do with it that no wonder it requires an entire unit. So the LD50, this means LD stands for lethal dose, and it refers to the amount of exposure that will kill 50% of the population. So if I had ants in my kitchen and I put out 2 teaspoons of baking soda and 50 of the 100 ants died, then my LD50 would be 50 teaspoons or whatever that I put out. That's how the LD50 is fixed. The smaller that number, the more lethal this thing is. So you can see that a taste or a drop is extremely toxic. But if it's a quart, it's practically non-toxic, because if you're going to drink a whole quart of something and you're still fine, well, then that's okay. Someone talked about carbon monoxide and how they became, acclimated to this and learned more about it. Here are some symptoms of some toxins. Carbon monoxide, you get pink patches on chest and thighs, and usually bright red lividity. Also, at the post-mortem, if you've died within 3 hours, the body continues to be warm. In the lab, if somebody had sulfuric acid exposure, if they ingested some of it, the vomit would be black. Nitric acid would be yellow vomit. So you learn all this in order to make a good deduction from what you're seeing at the crime. You've all heard about, if you've watched CSI, you will see something go, oh, his breath smells like almonds. It must be cyanide. So that's where that comes from. If it's a coffee brown vomit or a garlic odor, then that's phosphorus poisoning. But enough of that. Usually my students become really angry and outraged. They go, why is this being allowed to happen? Why are we being poisoned? Why is it uncontrollable? Well, we do have federal regulatory agencies. We have the Food and Drug Administration that's going to talk about what's allowed for us to eat and what should be in our medicine. If you ever watch a commercial, for example, the semaglutides that are being prompted to everybody, you will see this has not been proven by the FDA, because the FDA has to put a seal on it for you to actually come back and say, well, yeah, the FDA said this was safe, but now I'm having these side effects, toxic side effects. There's the Environmental Protection Agency. There's a Consumer Product Safety Commission. There's a Department of Transportation that's going to deal with emissions coming out of your car. It's also going to deal with everything that has to do with moving things. Then, of course, if you're at a job, there's the Occupational Safety and Health Administration, which is OSHA. And I'll talk more about this later on. One of the things that I made sure that my students learned by week 1 was how to use the safety data sheets. Many chemical companies put out their own. I liked the Flynn one. And also, I linked onto this, the nylon demo, because I learned something. When I was going through school, I loved demos, and I would watch demos and I would be wowed, not realizing that, hey, the demos actually also have their side effects that are not safe for me. But this is what a safety data sheet looks like. It has 11 parts, and the toxicology part is usually on section, it has 16 parts, but the toxicology is on section 11. It will tell you about the acute effects, the chronic effects, the LD50, and the target organs that are affected. Section 7 tells you about how to handle it and store it. Section 6 tells you how, if there's an accidental release, what to do. Fire marshals always want to see Section 5. And so most of these can be represented by codes on it. But when my students would be doing projects, the first thing they had to do, tell me what they're using. Second thing was to find the SDS of that chemical that they were going to be using, so that it could justify why they're choosing that as their source of activity on that. So with the hexamethylene diamine, this is one of the ingredients or reagents that you react with sepulchral chloride, which is, and this was such a hazardous demo, but I just remember relishing being able to see, oh, wow, this is what we're doing, and it's so good, not realizing that it really was not safe for me at all, right? Not at all safe for me, but this is what we love to see. So now that, you can go back and look at it and say, well, this is not safe for you, right? You can make better decisions of, excuse me, you can make better decisions of whether or not to use that as part of your interaction with the chemicals that you meet with your students. And you can also decide, excuse me. Yeah, you could make better decisions by saying, okay, maybe this is not what I want to use in my classroom. Maybe this is not what I should be exposing my students to. Maybe there's a safer way to do this, right? So that's what one of the things is. So I'm going to stop sharing for a little bit. Okay, there it is. Okay, so that was a safety data sheet. So my students learn to use it, and OSHA comes, every job takes you through, and you'd have what the right to know is. And I just remember that the the grounds person, the person who was in charge of the grounds of the whole facility, is the one that used to come and present to us, and he would speed through it, and all the teachers would want to sign out and leave. And yet, for me, that is like the most important source of information you can give all your employees and everyone who's in your facility. So it always just blew my mind how fast they went through it, and nobody was really interested in learning about it. So in the course that I teach, when we get to topic 4, which is toxicology, we want to find out, why is it important to consider toxicology? We want to find out what is essential that why is it essential that chemists have better understanding of what makes a molecule toxic, and why. This topic digs into the subject and how it relates and links to chemistry content. So 2 summers ago, there was the Superfund Site. There was a new green chemistry case study, which provided an educational tool to address toxic waste legacy and transform industry practices. And I wanted to show 2 examples. One of them is the Olin Superfund video, only because it's where Beyond Benign is headquarters. It is near Wilmington in Massachusetts. And then I wanted to talk about the Hudson River Superfund, because that's where I live. I live in the Upper Hudson. I have a beautiful creek in my yard. It flows right into the Hudson, but the Hudson is a tidal river. So sometimes the Hudson's flowing into my yard. So I was really curious at what we had here. So I'll show you a little bit of the video. Let me see if I can do that. Oh, geez. Let me try that. Chloe, do we have volume? Thumbs up. Can you hear it?
No, I can't hear it. No.
Superfund Site is
Oh,
located in Wilmington.
now I
Can you hear it?
Wilmington is an old New England town, first settled in 1665 and located about 20 miles north of Boston. With the construction of major interstate highways after World War II, Wilmington's population quadrupled. The boom quickly changed the town from a sleepy farming community to a prime location for the expanding chemical and defense industries. South Wilmington was designated a general industrial zone, and the town welcomed the new tax revenue base in its jobs. In 1952, National Polychemicals broke ground at 51 Ames Street and constructed many labs, offices, and structures to manufacture specialty chemicals for the rubber and plastics industry. As the facility grew and production increased, the company dredged wetland streams into ditches and created lagoons and ponds for their waste. Sediments from the ponds were stockpiled as well. Chemical manufacturing continued at the site under various owners, including Olin Chemical, which acquired the property in 1980. Olin's operations continued until 1986, when it was shut down and abandoned as a manufacturing site. Shortly after that, the site came under the state's regulatory authorities, and investigations began to identify specific contaminants of concern. By the mid-1990s, both Olin personnel and Wilmington water officials grew increasingly concerned that an underground plume of contaminants had been drawn into the adjacent aquifer, but none of the chemicals identified posed a known threat.
Okay. So this is the story, right? Industry comes in, economy is booming, everybody has a job, they're producing, they're reducing the tax level of the town. Unintentionally, they dump into the groundwater, and of course now, and then they move out and another company buys it. But the people who live around there continue to live there, and they are exposed to that. I want to just forward here. You can see that now a chemical has been identified. It's a carcinogen. It's one of the major ones that's being, oops, sorry. I don't even know how I got in. Okay. It's, it's identified as one of the main ingredients that are found into the water. Now it's a carcinogen. Animals are exposed. Children are sick. Kids have leukemia. Now okay, so now nobody wants to take responsibility for it, right? If you go a little bit farther,
Water. This study was the first in the nation to associate NDMA in drinking water with childhood cancer. The affected Wilmington families were unusual in their collaborative response. They proposed that a trust fund be created by the responsible parties that would collectively provide for the children's health and care and educational needs. This cooperative solution avoided lawsuit and has served the community well over time. EPA issued a partial record of decision in September.
All right. So what I encourage my students to do, okay, guys, this happened. Is grandma living with you? Is auntie there? Who was there? Who remembers? What can they tell us that, happened when so you can use all the resources available to you to just kind of help with that. So I like the all-in-one because that then gave me an idea to come up with ours. So the one that I chose was the Hudson one because of my proximity to the Hudson River. And also, the Hudson River, it flows from the north of New York all the way to the south of New York. So let me just stop share for a little bit. Get you back here and go back to sharing. Okay, so here's mine, the one that I chose. I chose the Hudson River, same story. I'm going to show you a little bit about the video.
The Hudson River in New York, once known as America's
Chloe, do we have volume?
March to the famous European waterway, played an important role in bolstering American power at the expense of decades of foul pollution. The health of the Hudson River has suffered greatly since industrialization took hold on its banks. Sewage and chemicals have infiltrated the waterway, disrupting ecosystems and killing species such as the bay anchovy, blueback herring, and white perch. In this video, we'll take a look at why NYC is cleaning up the Hudson River. The Hudson River, which runs for 350 miles, is steeped in American history. During the Industrial Revolution.
So that little bridge, that's the Amtrak bridge, and that's right here by my house. So this is the Hudson right here in Albany. It's our waterfront. It's called the Corning Preserve. We have the Rensselaer Port, the waterfront. Tons of fish. Next week, the fish are going to come in. I stand in there with my wading boots and there are fish swimming all around me. They're about 2.5 feet long, huge. But listen what they say about the fish in here.
Is steeped in American history. During the Industrial Revolution, it served as a transportation route for commerce and guided Henry Hudson in his search for a Northwest Passage. Industry created jobs, communities, and economic growth in the region. However, industrial pollution left its mark on the cherished river. The EPA has designated 200 miles of the Hudson River as a Superfund Site, making it one of the largest.
This is my riverfront right here where I live. That's the USS Slater, the warship that was used in World War II. So we're immersed. This is the famous Dunn Memorial Bridge that's in that movie Salt. So I walk by here every day all my life. But for about 10 years, from 2002 to 2012, GE, who was the main polluter in my area, in the New York City area and south of me was General Motors. In the Upper Hudson region where I am, it was GE, and the EPA mandated that they clean up. So there was dredging that went on. And the water has been tested. It appears to be safe. The fish can now be eaten. Kids can go out fishing. But it took 10 years to clean that up. This is stuff you teach your students. We go down, we get samples of water, we get kids from the Norman Scale Creek. We find kids where, is there a waterway near you? Bring in the water, we'll test it, we'll bring it in, and then we'll study the toxicology of it. So I know that usually people don't want to, or afraid to start this. Test soil, test water, test something that's near you so that it can become authentic for your students because that's where they live. And also encourage them to talk to relatives, encourage them to talk to neighbors, because sometimes your resource is right next door to you, right? Your resource people are right next door to you. So when I go back here, 5 minutes. Okay. Okay, so on the course, we read articles, we explore tutorials, and then we get lesson plans. So I'll show you what the lesson plan looks like. I was going to give you a 2-minute stretch break, but we had that big, you don't get that because I got a little, but I have teachers create lesson plans. These are examples of them. I'll make sure that Chloe shares those with you. We create lesson plans, and we like to use Flynn Scientific. A few years ago, Flynn Scientific teamed up with Beyond Benign, and a series of labs were put together. So if you're in an area where you think you don't have resources, you can order the Flynn kits because they come with the solutions and the equipment. And then eventually you can make your own because they're really very simple. But I like the claim, the Flynn Beyond Benign articles, because they take you through the 12 principles of green chemistry. They bring you all the material that you need. There's an overview. There's what you can use. And then there's data tables, and then teacher's notes, and even answer keys. So this is something that you can use in your classroom. It's a good start. Well, am I worried I can't teach toxicology? You can't get an industry? Well, then find out what salting our roads is doing to the plants next to you. So that's something we can do. And on my interactive, I have one more thing for you. Okay. We would have had a chance to share out. We've run out of time. I hope you got a lot out of this. I've addressed how you would go about implementing toxicology. I went through what useful ways have you found, what is a good resource. I hope I covered all that with you. And if you could just click on the survey in your interactivity, I'll love you forever. And thank you for your time. And happy Earth Week coming up.
Thank you so much, Annette. This was very rich, very entertaining in a way, and kind of encourages all of us to go ahead and do it, find information around us to get it done. Right now, I'm going to pass the mic to Michelle to talk about the professional development courses, right? Let's see, because we have just enough time to do so. Go ahead, Michelle.
Sure. So also Annette is one of the instructors for our advanced green chemistry, if you're interested in taking that. And also just to note that we have 3 courses. One of them is Sustainable Science, which is a short 3-week course. Then we have our 6-week courses, which is Intro to Green Chemistry. And then also the one that Annette is teaching, which is Advanced Green Chemistry, which you got a little taste of here. And something new that Beyond Benign is doing this year, particularly specifically for New York educators, is to have a fellowship. And again, Annette will be the mentor for that fellowship, and you will get one-on-one time with Annette, as well as some time with the peers who join in a small group. That fellowship will take place just following the advanced green chemistry course, and it will take place for the first semester, like from September to December, to give you that extra mentorship as you learn to implement these new tools that you'll be developing. So hope that. And the link, I posted it in the chat already. If you're interested, please go. And please go to that link. And then also, if you'd like to continue this conversation with Annette and see any more resources that she has, please go to the link in the chat that is called Toxicology and Authentic Engagement. It's a forum on the GCTLC. And Esther, could you go back one more? No.
The bridging.
The next one. The next one. No. Oh, yes, please.
No, bridging.
There. Stay there for a second.
There.
Okay, this one. Bridging the Gap is a workshop that's free for New York educators, taking place on the 9th of July, as you can see. And that one is Bridging the Gap from K-12 to higher ed to industry. So you can really see the education continuum, some vertical alignment. You'll get to meet some professionals of some high caliber professionals in New York. It's taking place in Rochester at RIT, as we said. We will pop the link in the chat if you're interested. Also, if you would like to have professional development credit for tonight. We will pop the link in there for you too. Sorry, I've just lost my screen a moment. We will pop it in just a second. Yes. Here is for the professional development credit, which will also be sent in the follow-up email if you've registered. So don't worry if you can't grab it quickly. And then here is the for the Bridging the Gap. We'll also send that in the we'll send all of that in the follow-up. So don't worry if you haven't grabbed anything here at all. Here is to continue the conversation again. And I think that is mostly all. If you'd like to go ahead and thank our sponsors, since we're running out of time here, thank you. Thank you so much, Annette. This has been an absolutely rich and wonderful discussion and interaction, and I learned so much about toxicology and the authentic engagement of students and the reality around them.
Yeah. Yeah. Thank you. Thank you, everyone. and
everybody.
have a fabulous evening. Thank you for coming.
Happy Earth Week.
Oh,
Bye.
yes. Thank you.